Good morning, everyone. Okay, so once again, we're just looking at these trig identities, and this is kind of the problems that I have on my mind, at least here lately, and at least for this playlist of this series of videos. Okay, so once again, if you're watching the other videos in the series, you know that we're trying to establish this equality. We don't have it, we're trying to establish it, and we want to work on either the left-hand side to start or the right-hand side to start, and then produce the other side as our goal or a target. And usually we'd like to work on the more complicated side. While both sides have a fraction, this is a little more complicated from the standpoint that we know cotangent and cosecant are fractions in and of themselves. So this will help us simplify what we need to do next on the next step. All right, so let's start with the left-hand side. And we do so by just writing that down. So we're going to begin with looking at the cotangent of squared x, over 1 plus cosecant x. And again, so the right-hand side, that's my goal. I've been calling that's my target. That's what I'm aiming at or aiming for. Okay, so let's come down and see what we get next. All right, so the first thing we want to do is probably resolve this in terms of what we think it's going to be. So the cotangent squared, we know that's from our knowledge base. So cotangent is cosine x over sine x. Okay, so we know that cotangent squared is cosine squared x over sine squared x. So we're going to put that in. That's what it is. And cosecant x is 1 over sine x. All right, now that may look like a fairly complicated fraction that we're considering. And technically it's a complex fraction, so let's add in, which you don't need as long as you do it correctly, but let's just add in these parentheses so it'll be clear what the actual numerator and denominator of the large fraction is. Now, the simplest way to handle this, since it's a complex fraction, is actually in some ways makes it easier. Let's multiply it by the number 1, which is anything over itself. So what I'm going to choose for the number 1, this is called clearing the fractions. So what I'm going to choose for the number 1 is sine over sine, but I'm going to write it like this. Sine x over 1 over itself. Anything over itself is 1. So instead of just writing sine over sine, like this, which is more simple, of course, that is also a version of the number 1. These are equivalent, by the way. But look, when I multiply the two numerators, I want the fraction bars to line up so I don't make a mistake as to how to handle that. Now, in the denominator of the large fraction, I'm going to do two things. I'm going to distribute, right? And so it's for this piece, these two, they're lined up perfectly. And then on this one, when I distribute, it'll be 1 times anything as itself. And I'll just write sine x down there. Okay. So let's do the numerator first. So what will happen is this sine will cancel with one of those signs in the denominator. So in the numerator then, I get cosine squared x over sine x, just one. One of them's gone. You had 2 sine terms in the denominator. 1 got canceled. And now what happens here? Let's do the left-hand one first. Sine x over 1, which is just sine x times 1, is just sine x. And sine x times 1 over sine x, those will cancel, just giving me the number 1. To pause and take a moment to look at that. while I freshen it up a little bit. And again, technically, I'm going to put it in. I'm kind of a little pedantic on this. So certainly when I'm explaining, you really need parentheses there so you can certainly see what the numerator of the large fraction. Okay. So, and by the way, I could have done the common denominator move down here, which would have, I'll do it on the side, which would have been sine x plus 1 over sine x. And that might have been a little simpler when you multiplied it by this term, where you would just get sine x plus 1 after the fact. You can work that either way. Okay, so let's simplify this. You can do a couple different things, but let's just take a moment to simplify this. And some people call it the keep, change, flip. And I want you to work this out yourself. I'm going to go straight to the steps. See if you can figure out how this occurred, and I'll kind of give you a hint. So the hint would be that, and I normally wouldn't write this, but since I'm giving it away, the hint, you would then write this as itself. Actually, I'll leave that in different color, over 1. And then you would just do the keep, change, flip business. But anyway, once you do that, this is what you're going to get. Okay. Pause the video if you need to. Take a moment, work through that step. That's going to be crucial because that is the next step. And again, remember, as you're following this, or anyone or any reading, you need to make sure that you're not only able to do each step, but to think about, would you have thought to do that at that stage? And if you're saying, well, no, you wouldn't have, well, then you'd have to say to yourself, well, what would you have done? You're just looking at this term here. You need to start simplifying it, and you could do what I'm going to do next, which is use the Pythagorean identity here. But even if you did that first, you're still going to do this type of simplification move at some point. All right, let's proceed. Again, now, cosine squared, what is that equal to? Well, we know sine squared plus cosine squared is 1. So a popular variation of our Pythagorean identity is cosine squared is 1 minus sine squared x. So let's put that in and see what we get. All right, so the numerator becomes 1 minus sine squared x, because that is what cosine squared x is. So I'm replacing cosine squared x with 1 minus sine squared x, which is coming from our knowledge base. We're going to recopy the numerator, correction, the denominator, since we're not doing anything with it. Right now, our attention is in the numerator. Okay. Now you can kind of see it. So now this is where, you have to kind of look at our target. Okay. So what is our target? Well, our target has a lone sign in the denominator, and we've got that, so that's good. So the further simplification has to take place, kind of like by the process of elimination, in these two terms. Okay, so now what we need, and it's not really a knowledge bit, I'll put it over here in purple. It's not really a knowledge base in terms of trig. It's really the difference of squares. We know that a squared minus b squared is a minus b times a plus b. So this is certainly part of the knowledge base, but it's algebraic rather than trigonometric. So let's go ahead and use that. So you can see that the numerator is a difference of squares. So let's do that. 1 minus sine squared x should be 1 minus sine x times 1 plus sine x. Recopy the denominator. Once again, our attention is in the numerator. And now, if you're looking ahead or you see it, now these aren't written identically, but remember, 1 plus sine x is equal to sine x plus 1. So saying it back in the old algebraic days, addition is commutative. A plus b is b plus a. and we certainly know that. But what that does for us, it says that this term, 1 plus sine x, will divide out or cancel with that term, which is also 1 plus sine x. Now let's see what we're left with. And if you're looking back at the original statement, this is what we wanted to show. This is my right-hand side, my target. 1 minus sine x, all divided by sine x. And that's what I wanted, so that's my target. I achieved it. I achieved my target. And so therefore, we have established the identity. Cotangent squared x over 1 plus cosecant x was what I ended with, which was 1 minus sine x over sine x. And again, we could have chosen to work on the right-hand side as opposed to the left-hand side, but that would have been more difficult to do. Okay, in fact, let me work this again with an alternate method. Just and one thing I want to underscore is that there's not just one method you can do these problems. Most of the time, there's not just one way to do it. Okay, so let's try to prep the knowledge base for us. What we're going to need is the cotangent squared formula from the Pythagorean. So now this one's less known. Here, let me put this one in. Secant squared x, and I did use this one on just my previous video, is tangent squared x plus 1. And it's also true that cosecant squared x, can you guess it? Cotangent squared x plus 1. Now, what we need is a variation for this. Now let me show you what I'm looking at. Look at this right here. Cotangent squared x is in the numerator, and I'm still going to work on the same left-hand side, but what I want to do is let's solve this for cotangent squared x. So if you weren't familiar with it, or you knew this one cold, off the top of your head, but not the other one, then this is what you would get. You would say cotangent squared x is cosecant x minus 1. All right, now let's apply that on the left-hand side, which is going to be my same side that I worked on before. So let me recopy the problem, and then we'll apply what that is from our quote-unquote knowledge base, and really which is our memory. And maybe it's not your memory directly. Maybe you remembered this one, and you did need, in fact, solve to get this. Okay. So what is cotangent squared x? That's cosecant squared x minus 1. Let's recopy the denominator. All right, so now, again, difference of squares. We used this on the last problem, so it's not surprising. This is an algebraic recollection, so it's not surprising that we're going to be using it here. So again, I have the difference of squares. So I'm going to apply that knowledge at this stage, and I'm going to get in the numerator cosecant of x minus 1 times cosecant of x plus 1, again over just the denominator. I'm not working on that now, so that's a recopy. And now again, once again, we saw it in the last version, cosecant of x plus 1 is the same as 1 plus cosecant x, so these will divide out, cancel. Some people say both, some people don't like the term cancel. So what are we just left with? Cosecant x plus 1. Now that's not, now take a glance back up, cosecant x minus 1. That wasn't our right-hand side. Now we stop for a moment and breathe. Look, our right-hand side has only signs in it. So what we need to do is then use our knowledge that cosecant is 1 over sine, put that in. So let's do that. So what is cosecant of x? It's 1 over sine x minus 1. And how do we add fractions? Common denominator. So 1 is sine over sine. And again, I'm doing these last 2 steps kind of slow, so this second method is a little quicker. It's being slowed by being a little pedantic here and writing out these steps, but that's okay. And finally, we're done. This is 1 minus sine x over sine x, which was my right-hand side. We write our final statement, and we have hit our target, and the identity has been verified. So this is a little shorter. Yes, it is. It's a little shorter than the last one. But again, okay, I've got it fitted to the screen. It's not necessarily superior because you have to remember, did we know this? And this is what you have to ask yourself. It's not as a student, but as anybody who's working the problem. Would you have made this move? Well, if you didn't think of this, then you would probably not have thought of this. So you would not have been able to do our very first move, which meant you would have never moved forward in this method 2. And so this is why method 1, which is a little longer, it's a little more advantageous in the sense that it's generally more achievable by most people. This one only required the basic Pythagorean identity, which we're all supposed to know, and we're all supposed to know these cold as well. And again, yes, this one probably is the second most common of the Pythagorean, and if I had to rank them, this would be the third, right? Again, it's still something you're supposed to know. But again, if you hadn't thought of it, you would not have been able to proceed with method 2. Anyway, I hope you enjoyed this video and the comparative analysis between those 2 methods. We'll see you next time.